Hello, Chad Gill here. I'm the host of the This is Concrete podcast, where I talk to leaders in facilities management, architecture, contracting, and more. This episode is brought to you by Concrete. Concrete is a concrete polishing and coatings company with nearly 20 years of experience working in commercial, industrial, and residential markets. So whether you need smooth transitions for a warehouse traffic, a show-stopping lobby floor, or a seamless concrete accent wall, we can provide the skill and imagination you need to make your concrete uncommon. So what are you waiting for? Visit us at thisisconcrete.com to learn more about Concrete today. On the show today, we are being joined by Josh Jones. He's the president of Substrate Technology and a technical trainer for the products that they sell. He's a flooring specialist and a supplier with almost 30 years of experience. He's also skilled in surface prep, concrete polishing, thin mill coatings, YouTube video production, clearly should be on this list. He's also managing director for Impacts Americas, which sells shot blasting equipment and other prepping tools for surface preparation. So Josh, thank you for coming on. I appreciate you taking the time to kind of get together with me.
You're welcome. Thanks so much for the invite.
Yeah, so the YouTube channel you've done, man, that thing is that is garnered a lot of attention. Lots of I just swear I'm always like looking at it. It's like, where's Waldo and what's Josh doing today? It's like a great combination.
It's been a great way to get the word out, on my favorite topic, surface prep. It's another avenue to get the information out to hopefully the people that need it.
So why surface? Like, what draws you to? Well, first off, where's the dog come from? We'll have to get that one out of the way early. So it's in like all the videos. It's great. I love it because you look for the dog, and then then like I think one time there wasn't a dog, and I was like, well, maybe the dog got COVID. I don't know what happened.
The dog. Well, the thing is, when I started traveling around with the ProMaster and going across the country, a friend of mine gave me the plastic dog and said, "Do you want to take this dog on your trips?" So I did. And then it kind of became a social media gimmick. And then some places I went, people actually wanted to get their pictures taken with the dog. So the dog stays in the ProMaster and rides around wherever I go. So it's maybe a good luck charm. And then also something that entertains people, I guess. But yeah, it's not not much of a story, but he makes every trip that I do.
That's awesome, man. Sure, to give you somebody to talk to. And then, problems don't really start until he talks back. Then it's a bigger issue then. So surface prep. I know how you come to grinding and stuff like that, but what made you suddenly start focusing on surface prep for the education side of it?
Well, surface preparation is something that we did as contractors back in the early 90s. I would say that back then it was more a matter of just routine and doing different processes based on manufacturers specifying it be a grind, a blast, a scarify, whatever it might be. In the last couple of years, with the advancement of coatings technologies and the nature of the materials and the speed at which they change in hardness and the time it takes for them to cure, surface preparation has become even more important because these coatings products are going down and within sometimes 30 minutes are almost walkable, which means that surface that they're being placed upon have to be ready in order to allow the absorption of the viscous liquid. And surface prep is important for that reason. And then also, when it comes to social media, there's a lot of failures out there that are directly related to bad surface preparation. And it's kind of just become a thing that the audience, as it were, on social media seems to enjoy just hearing more about how to make the concrete ready for a new coating system. So I've kind of just followed what appears to be of interest to people.
What is it that, what are like the key ingredients of surface prep? Because you would think, okay, it's like paint, if it's clean, I can put it on there, but there's a lot more to it than that.
Yeah. When it comes to surface preparation, the way that it's been explained to me is the material, of course, is installed as a liquid, whatever the starting viscosity might be. So it goes on very thin. And the idea is that it's going to absorb into the concrete. In this case, we'll just keep it with concrete. It'll absorb into the concrete. Now, in a short amount of time, as it reacts, it's going to start to thicken and eventually, obviously, reach its full strength. But it's that window of time from where it goes from a very runny material that's going to be more apt to absorb into anything that it can, until it starts to thicken to the point where it'll then harden on top of the surface. So the importance is getting the floor ready by making it clean And I just say making it thirsty. So that concrete, which its natural tendency like a sponge is to absorb liquids. So if I get it clean of dust, of any other surface contamination, and then introduce that coating to the top of the concrete, it's naturally going to want to wick or absorb into the surface of the concrete before it thickens, and obviously before it hardens. So that's really the gist of it, is getting the floor ready so that the material can soak into the concrete. And then once it hardens, after it's soaked in, I just call it like tree roots or just roots. It anchors itself to the pores of the concrete so that when it's tested later on for adhesion, the surface of the concrete will actually fail before the coatings bond to itself ever will.
Yeah, I think that's a good point. It doesn't chemically stick per se. It just seeps in, and kind of like you said, I think roots is a great analogy for what it does. It gets in and hardens, and then it forms a structure that won't pull directly free of a pore. And then it's just kind of mechanically locked to the surface of the slab. So how do you, when you're talking about surface prep, I guess, is the preparation different based on the speed of cure?
Well, I usually will defer to the manufacturer of the coating. A lot of people will ask me what should be my method of prep before XYZ coating. And my first answer is always to check the tech data sheet, because in there it's going to say what the surface preparation should be. If it doesn't, then I would say call the supplier. But normally, when it comes to thin mill coatings, bare minimum I've seen is a CSP2, which is a diamond grind. I personally prefer a diamond grind before I do any other prep anyway, because usually old sealers, surface latents, whatever might be on the concrete, as well as elevation inequalities that I can smooth out, that's going to take place when I diamond grind it. So I'm going to grind pretty much everything. As far as shot blasting, if it's a system that requires that, then again, it would be called out in the tech data sheet. So I look at it more from the standpoint of what the coating demands of me, as opposed to what I prefer to do. And if I'm not sure based on the documentation, I'd call the rep.
Sure. What are the times when grinding is not a good preparation for a coating?
I can't really think of one, only because when it comes to concrete, it's rarely ever perfectly flat. If, however, it's deemed as flat enough that it doesn't need to be ground, then I would say you could go straight to shot blasting as an example. Maybe it's a urethane cement and needs a bush hammer. It really depends on the system. If grinding would be in some ways unneeded on a floor, but the majority of the floors that are being done these days, even at joints where there's elevation inequalities at joints, might have to be some grinding that takes place there. So I really can't think of a drawback to grinding. It doesn't necessarily mean that when the grinding is done, after I vacuum it, it's ready for a coating. It just means that maybe the floor has a flatness that doesn't require that the grinder is needed. And also maybe there's no surface latents that need to be removed that a diamond grinder would be appropriate to use.
Right. And then I think that's one of the things you're a big proponent of that I've seen is grinding and then shot blasting. Even if it's a brush blast, even if it's a method of just cleaning the slab. I mean, your video showed it's a dramatic difference, between what you can broom and vacuum versus what you can shot blast. Why is the shot blaster so good at doing that cleaning?
A shot blaster operates under negative pressure. Like a grinder, when we plug it into a vacuum, it's to collect any of the dust that would otherwise escape from the cutting area. But in a shot blaster, the system works because of the dust collection. Along with the motor that accelerates the shot, there also has to be vacuum or air movement inside the chamber of the blaster. So that means as the shot is making the waste or attacking the surface as the media hits it, it's done under negative pressure. So as soon as the waste is made, or in the case of dedusting, just disturbing the surface dust, it automatically is extracted from the surface of the concrete or where the waste has been made. So there's no time for it to settle into the concrete. It doesn't get pushed into the concrete like diamond stones or discs might do. It actually lifts it like a wetback almost, except dry. When the work is done, the floor is, as can be seen in the videos, the floor is immaculately clean because the dust that was made has been removed from the area as soon as it was made.
What keeps people from doing that? I mean, is this a very timely step? Is it an expensive process? Why Why wouldn't you use this just as your cleaning method?
The process is actually pretty cheap compared to grinding. Let's say it's fast. I mean, a little 110-volt blaster that I normally run around with, that'll do a 2-car in like 12 minutes. So it's actually faster than wand vacuuming it if you had to do it, let's say 2 or 3 times. The one reason I would say people would hold off on doing it, the primary reason, it'd be the expense. I mean, it's a machine that, is much more expensive than a vacuum wand, though it does much more work than a vacuum wand. It is an additional cost. But to me, I look at it as cheap insurance if I have the hardware to use. But certainly it is an investment in the equipment that has to earn its keep in some way when it's being used on these jobs to collect that last little bit of dust.
Yeah, it's certainly cheaper than the opportunity cost of a redo floor.
Of course.
Yeah, I mean, just one of those can pay for a shot blaster a couple times.
Mhm.
So I think one of the advantages, like in addition to that, is the fact that grinding is just going to get that surface, that layer. You do flatten it, and that helps with coverage and millage control and stuff like that. But then there are nail pops and divots and stuff like that. And if it's not on the surface, a grinder's not really gonna prep that area either.
Yeah, and that's a good point. Tool joints, like control joints that are tooled in, there's really no, if you're going to fill them, there's really no good way to prep them other than, if not shot blasting, literally having to take a saw blade and run it along the radius of that tool joint. A shot blaster makes it much easier to do that. Garage floors, any floors really that have the surface pits or nail pops, especially salt damage inside garages, running a shot blaster over it is going to get it cleaned down inside those voids. Grinding across the top of that, of course, the surface the diamonds touch can be cleaned, but it's pretty common to see floors that have pitting that have been ground, and then after vacuuming, you can see the pits haven't even been touched. A shot blaster will profile and clean down inside those pits. Of course, patching has to be done to fix the damage, but the idea is that those areas that the grinder couldn't touch are now going to be clean and thirsty, so that whatever repair material is used, it has a way to absorb and bond to the surface of the concrete.
Yeah, and I think that's a great way of putting it. And then in addition to that, it's the idea that grinding is I guess planar. It's not, as opposed to be a 3-dimensional hit like you're talking about with shot coming down or any kind of media that being thrust at the, whether it's hydroblasting or pressure washing even, you'll see that it'll start to get underneath flakes and generate pressure and pop things free that maybe a grinder will glaze over from time to time. And I think shot blasting does a really good job of freeing up stuff. And some would say that you can damage a floor. I mean, certainly you can damage a floor with any tool, that you'll create pockets and stuff like that. But I don't know that I agree with it. I think if it's loose, it should come out anyway.
Yeah, I agree. If there's anything that's loose in the floor, the manufacturer of the coating, speaking, on behalf of their products, let's say, they really aren't wanting to see their material be responsible for fusing a weak surface back together. Certainly some products can't do that. Some products are used because the surface needs to be fortified. But when it comes to the concrete, if there's something that's loose there, that needs to be removed so that then the proper repair material can be placed to fill whatever void it leaves behind. Because it's a future liability.
Now, would you say that, what is like the most pushback or like from your videos and stuff like that when you're showing these things? What are kind of the most naysayers or the pushback that you get where somebody, against these type of techniques?
I would say that it's probably the conventional thinking that it's going to damage the concrete. And it certainly can, without a doubt. I mean, I can damage the concrete or, let's say, misuse the equipment, whether it be a blaster, a grinder, or a scarifier. I can use any of those pieces of equipment that'll cause me work later on trying to fix it. A blaster, though, by its nature, cannot help but blast whatever the blasting window might be. In the case of the 110 volt, it's 8 inches. So if I let it sit in one spot, or if I move at an erratic pace, then I'm going to get these random little cuts of an 8-inch wide by 2-inch wide window, where I've actually put a rectangle into the floor. So if I do that, I'm going to have to fix that with material, because obviously I've removed concrete where it didn't need to be. If I overlap too much, if I have the blast wheel out of adjustment, it's going to hit harder on one side than the other. So again, if the equipment is misused or isn't understood, it can certainly do more damage than what it's intended to do. But by its nature, just like a grinder, it only knows how to hit the surface with steel media. And when it does that, it's going to erode the surface. It's on the operator and how they move the machine, so it's more uniform.
No, yeah, I would agree with that. Yeah, it's always trying to find that consistent pattern. You can deal with anything that's consistent a lot easier. So when you're doing the surface prep and stuff like that, a lot of what you end up doing is exposing these porosity conditions or pores and stuff like that. And you've kind of done a lot of stuff on your videos with how you're grouting slabs to fill these. Now you got this thirsty slab. How are you filling it up? And I've seen you do trial on urethanes. I've seen you do, I think, a polyurea. And then the one that I've probably utilized the most is the epoxy and the marble flour. Can you talk about kind of like where you use those and what the pros and cons of those approaches may be?
With regard to surface prep or polishing?
Well, probably maybe polishing, or I guess it's probably really more polishing. I mean, for surface prep, I mean, those are good repair methods, but I guess the porosity is good if you're going to put a coating down. I guess it leads more into the polishing side for the grouting after you've done that surface prep.
Okay. When it comes to the polishing, I'm normally not going to put a blaster on the floor unless I do have nail pops and pits that the grinder can't prep and I need to do some repairs. So for the most part, the last thing I'm going to do before I start, let's say, the refinement process of the polishing or the grouting, the preceding step is going to be grinding of some kind, whether it be an 80 grit metal or a 120 metal, depending on the system. At that point, once the floor is clean and the surface has been dry, then my preference would be to use an epoxy and marble flour, which you had alluded to, because I want something that's going to, one, be durable. Using a reactive epoxy, of course, that's going to be a durable material. It's not a single component water-based latex-based product. It is a reactive high performance resin. I'm going to use that over the surface of the concrete to absorb into those fine holes that pretty much every slab has, depending on exposure, so that those holes get filled in and kind of line the bottom of them. And then once that's done, broadcast the marble flour, which is just pulverized calcium carbonate. There are different grades that can be purchased, but the idea is that I'm taking a solid particle and broadcasting it over the wet epoxy that's been skimmed over the surface. And then with the machine, it doesn't really matter these days which machine, but with the machine and the grout pans, which are a beveled edge tool, the idea is to compress with the machine and those tools, compress that solid material, the calcium carbonate, into the holes that are lined with wet resin. And by forcing those two together, that's going to cement that in place.
And that's kind of what you're talking about. You need that solid media, because the meniscus and the surface tension of the liquid, it's like traps an air bubble in the bottom of the hole. And then you cut it and now you just got another hole again.
Right. Yeah. The idea is what you're getting is the benefit of a grouting material, as though it was like kind of like the old days of doing tile grouting or even marble filling, which they still do, where it's more of a slurry type material. But in concrete polishing, the holes are so small that we don't have the ability, or to my knowledge, there's nothing that exists that can go down as a slurry coat. So in other words, be a trial grade product that's fine enough to find its way into those very small holes in the surface of the concrete. So we let the resin do the job of finding them and soaking in. And then with pressure, we force that powder into that wet epoxy, and the two just, obviously, as they're pressed together, they stay together. And once that epoxy cures, it could be on the level of hardness and abrasion resistance of the concrete, even, because it actually becomes a uniform part of it.
And I can attest, it's a way that we have grouted a lot of floors. We really, really like that approach when we have the time and the budget. It's not an inexpensive process. I mean, it's definitely dropping back and doing some stuff. But as far as performance to a floor or cleanability, it's a tremendous advantage. When do you use that as opposed to doing like a trial on urethane? If you're doing, is it just depend on the size of the holes?
Well, the urethane is different than the epoxy because primarily because it's so much faster. There's no time with the urethane that I've used, the few that I've used, there's not enough time to do any kind of extra work. I mean, they're made to cure quickly. So they will go from low viscosity to almost unusable within about 5 minutes at 70, 80 degrees. So there's not a lot of time to work with it. What it does give me the ability to do, though, is obviously get an area grouted quickly, because the quicker it cures, the quicker I can cut it, and the faster then the work can continue. It is a lower viscosity material than the epoxy, so that's a good thing for soaking in and saturating the surface, again, moving quickly. But the issue with it is that it doesn't have any extra filler that's been added to it. So if I have very fine porosity, that very thin liquid will help. It will always increase the clarity of the polish because the floor will become more dense. But if I have holes that are bigger than, let's say, the size of a pinhead, those holes are going to be so large by comparison to the low viscosity liquid. The liquid will go in, but it'll line the bottom of those holes and the void will still be there. Though the floor will look better, it won't fill those holes because they're too large, as well as that epoxy and powder mixture.
We're kicking back to surface prep approach. You mentioned bush hammers. I know you've done some videos on that too. So it's a great looking finish, and we've done it on a few driveways and that kind of thing. It's it's non-skid and that kind of thing. What are you using those just to get to a higher CSP? And what moves you from a grinder, from a metal diamond or something like that, abrasive, as opposed to an actual bush hammer?
Well, in the case of surface prep, aesthetics are one thing. The bush hammer finish for driveways, walkways, it's a good looking floor. But when it comes to using it for surface prep, I'm only going to use it if the product mandates that I use it. So if a product calls for a CSP4 as an example, then that usually is going to mean bush hammer. It's usually when urethane cement, epoxy mortars, some of these products that go down thicker and have a higher amount of tension as they cure, they need that profile. Of course, they need it clean, they need it to be absorbent, but they also need that texture, because some of these products, when they cure, they create so much inner tension that if they don't have that profile or that texture to grip to, they'll literally peel themselves up like a potato chip off the floor, because they pull so tight as they cure. So again, it's something that if the tech data sheet says bush hammer, that's when I would use it. I tell contractors, I might have a certain process that I do, but the coding is still my boss. The coding still tells me what I'm going to do, as opposed to what my favorite way of doing prep is.
On a bush, is there fear that the bush hammer, it's just a roller with spikes on it? Is there a fear that you're fracturing the surface and you're weakening the top of the concrete?
It's certainly possible. There is different science behind, whether or not there's microfracturing taking place. There's also been studies on scarification causing microfracturing. That is possible as well. My personal opinion is, if the coating and really the contractor is on the hook all the time. As soon as the coating is placed, the contractor is responsible. So my advice would be that if I'm told that I need to do a bush hammer, if that's what the tech data sheet says, and I have any concerns or reservations about the prep method and microfracturing or anything else, I would definitely check with the manufacturer to get their take on it. My personal opinion is, I don't believe on a floor that has, let's say, acceptable compressive strength, which is also going to be listed in the TDS, let's say 4,500 PSI. If I'm dealing with a floor that has good inherent strength and is structurally sound, all I've done is dented the surface with the spikes. I may have chipped away sand particles, but if it's a sound slab, my work should not have undermined the inherent strength of that slab. The top is profiled and it's broken away, but my personal opinion is microfracturing should not take place beyond what the manufacturer expects based on the surface preparation method that they had specified.
Would you follow behind bush hammer to de-dust that with a shot blaster, or is it a little too rough?
I've done it. It is better. I would just say from a cleanliness standpoint, it is better. However, there's a video where I shot where I expected a change, like after we grind and back and then blast, you see a big difference. After bush hammering, it really didn't look that much different. I know it is more clean, but I would say the bush hammering is a cleaner process and easier to clean up after, because the pieces it makes aren't talcum like powder bits that have been created by diamond grinding. They've literally been broken away and pulverized from tips of carbide spikes. So the sand grains aren't nearly as friable or fine as grinding dust. So it always helps. But to answer your question, a vacuum or a blast, to me, the surface looks the same either way.
And that would make sense in that the grinder does have a tendency to push things down, I think, into the structure of it. Whereas again, you just don't have that kind of contact from a bush hammer. It's all point contact, breaking away and popping up. So it's kind of ready to be vacuumed a little quicker than a grinder per se. I don't know. So any other like words of the wise, like, hey, the lessons you've learned, or, like the top two things you're rolling in to start into this stuff, and you're like, I mean, just don't do this. I've done it. There's no reason for you to do it. You can avoid this.
Well, different resin manufacturers or different formulations are a little more or less forgiving based on, the way that they're put together. What I would say, metallics are a thing that I don't care to ever do again, because metallics take a lot of patience, a lot of practice, and low expectations.
You gotta have discipline to stop messing with metallics too. Like you put it out, doesn't look good, and you're like, I hope it looks good tomorrow.
Exactly. The other thing is, and this is a difficult one, after I do all the surface preparation and I make sure that my ratios are correct and I mix it the right amount of time and all this other stuff that has to take place, because this chemical, the resin doesn't have a way to think for itself. It can't make up for my misstep, let's say. So if I mix it correctly, it's going to do its job the way it's supposed to. However, temperature is one of those things, and humidity as well. Let's just say environmental conditions. Temperature of the slab, temperature of the air, humidity also is worthy of noting. The temperature of the material, all this stuff is going to factor into, if it's done correctly, that the result will be successful, that it will cure the way it's supposed to, look the way it's supposed to, and cure it in the time that's expected. It seems like a small thing, but for the expense of having a mistake, because I could have waited 2 hours to install something, let's say when it stopped raining, or when the temperature outside was going to come up. And of course, I'm speaking in a place where I have no control over the environment, garages as an example. If I'm in a climate controlled area, then I can pretty much command what it's going to be. But if I go ahead and I put this material down and the temperature or the humidity is not acceptable to the formulation cannot think for itself and wait to do what it's going to do until the weather is favorable. So I would always say that the technical data sheet, once again, will say what those acceptable ranges of temperature and humidity are. And if you're not sure, call. I always say the reps, they earn their money helping customers. So before, make a mistake that's going to be expensive, if it's off just a little bit, just make the call and ask, because the coating will not make up for environmental conditions that it's not meant to be used in.
No, I agree. And if you have some A left over and you don't have any B left over, you have a problem. So you should have equal proportions of that.
Yeah, they don't overfill the buckets.
No, there's no extra there. Yeah, that was there. And then my favorite, where I'll get a mad call or a scared call from someone like, hey, you think if we just roll on some hardener, it'll go ahead and harden up? No, I don't.
It's been tried. And it usually doesn't work.
I've tried it, but I think we've all been there, and we're all like, well, maybe this will be the one time it'll work, but no. No, I mean, Josh, that's great. Again, the YouTube videos are fantastic. They bring a lot of awareness to kind of show. I think a picture's worth 1,000 words, and a video is probably worth a book. So that's keep doing what you're doing. It's awesome, and it certainly works out to help a lot of us contractors to take that video and send it to customers. I mean, I think I've sent your videos to customers multiple times as a way of saying, hey, here's somebody else who doesn't have a dog in the hunt, does have a dog, but not in the hunt. And, and show that here's what he's saying, similar to what I'm saying to you. And I think that helps. I think people are visual learners, and they get it, because some of what we do, it's a little mysterious, and it's bad when it comes up later and you haven't warned them.
Yeah, exactly. No, I very much appreciate it. I enjoy sharing what I've learned, and just get the word out. So thanks for the invite, and also thanks for doing this, because it helps raise awareness, and it educates people on the right way to do things.
Yeah, I think so. I think an educated customer is a better customer. So it just helps us do what we want. Well, we'll put a link to your YouTube on their on the posting and send it out to you. And again, thanks a lot, Josh, and really appreciate it. Thanks for being on.
You're welcome. Thank you.
Thanks.